Assalamualaikum and hi. My name is Muhammad Hafizuddin Hamis bin Halim, and my invention is modeling and simulation of compact Vivaldi antenna for fault detection in power system. Let's check out what it is detect. So, what fault for detect or what fault for detection? Firstly, it will detect the partial discharge in the range of 2.4 to 3 GHz frequency, and then it will detect the arcing faults in the range of 2.8 to 4 GHz. This is the explanation of the fault. So, what is arcing fault? An arcing fault happens when electricity jumps across a gap between two conductive points, such as broken insulation, loose connection, or damaged conductor. Instead of, follow, Instead of flowing along the normal conductor, the current arcs through the air or across the grid insulation, produce intense heat, spark, light, and electromagnetic radiation. If not detected, it can damage equipment, ignite fire, or cause explosion. Arcing generates strong electromagnetic emission, especially in the gigahertz range. Secondly, what is the partial discharge fault? A partial discharge fault, or PD, is a localized electrical discharge that does not completely breach the insulation between conductors. It often occurs in small defects, voids, or cracks within insulation material. PD usually happen at high voltage stress point and produce high frequency signals and sometimes light or sound. Through a small at first, repeated PD can gradually crack insulation and lead to complete breakdown over time. Tiny discharge inside transformer insulation or high voltage cable joints. Why this invention is important? It also can prevent damage and hazard, such as detect arcing and partial discharge early before they can cause fire, explosion, or equipment failure. Secondly, it is cheaper and practical. Overcome the cost, size, and accuracy of existing methods like ultrasonic, infrared, or digital recorders. Because of it cheaper, it is the compact size, it will give you the cheaper price, only 6 times 4.5 cm, suitable for space-limited areas like substation, MSB room, or control cabinets. For the future ready, it can be integrated with IoT or GSM for real-time monitoring in smart grid and renewable energy system because of the compact size. Okay, we want to tell you about the problem statement and the objective. First, problem statement. The first problem is power systems are exposed to faults like arcing and partial discharge. Such faults produce high frequency electromagnetic signal range the 2 to 4 GHz. Existing detection method can be bulky, costly, or ineffective in noisy environment and limited space. It also need for a compact space efficient antenna for early fault detection. So the objective of the invention is to design the compact Vivaldi antenna using CST Studio Suite within antenna operate in 2 to 4 GHz range with reliable fault detection to simulate and analyze key parameters such as S parameter, S11, VSWR, voltage standing wave ratio, radiation pattern, to compare the outcomes of the result based on their performance and expected performance standard. So I want to tell you about the Vivaldi shape. The Vivaldi shapes. The Vivaldi antenna, also called a taper slot antenna (TSA), it is a type of ultra-wideband antenna that radiates in the end fire direction along its length. Its design is based on a exponentially taper slot edge on a conductive plate which gradually guides and radiates electromagnetic wave. The exponential taper, the flare opening of the antenna increases gradually in exponential curve. This transition reduces reflection and allow the antenna to operate efficiently over a wide frequency range. In this project is 2 to 4 GHz. And then the microstrip feed line. The microstrip line is used to feed the antenna and transition the signal into taper slot. This ensures proper impedance matching with the 50 ohm system to minimize signal loss. The compact dimension, while traditional Vivaldi antenna are especially large This design was optimized to 6 4.5 cm, making it compact while still maintaining high gain and wideband performance. The performance features that we target is the return loss S11 below -10 dB. It means it has a low reflection efficient signal transmission. And secondly, VSWR we want to near one because the near one is um, the perfect reflection. And then this project we achieved at 1.15. And then the directional radiation pattern, it is focused energy forward, which is ideal for detecting fault-related electromagnetic signal in power system. In short, the Vivaldi design combined wideband, high gain, and directional radiation in a compact form, making it highly effective for fault detection applications like arcing and partial discharge monitoring in power networks. This show is the design pattern. For the result and discussion, first of all, we want to tell you about the return loss S11, and secondly, we will explain about the radiation pattern, and lastly, we will tell you about the voltage standing wave ratio (VSWR). So this is the S parameter S11. In this invention, we achieve a reflection coefficient of less than -10 dB in the desired frequency range, ensuring a good impedance matching. The best result is get a compact antenna with 2.55 GHz at -22.69 dB. This is the lowest return loss that I get in this invention. So, the radiation pattern. This show is the forward or the directional radiation pattern. A radiation pattern is like a map that shows how an antenna sends out of or receives energy in space. Instead of radiation equally in all directions, most antennas focus their energy more strongly in a certain direction. For the Vivaldi antenna, the radiation pattern is directional, meaning it concentrates energy forward. It makes it very useful for fault detection because the antenna can look more precisely toward the area of the interest, instead of picking up unnecessary noise from all around. Especially, we put the antenna in the noisy place like MSB room or power generation room. A good radiation pattern ensures that the antenna is efficient, accurate, and less affected by interference in noisy environments like power system. And lastly, the voltage standing wave ratio. In the red columns, we get the good VSWR, which is 1.158, nearly most to 1. VSWR tells us how well the antenna is matched to the transmission line, usually 50 ohms. If the matching is good, most of the signal goes into the antenna. If not, part of the signal bounces back. This shows VSWR near to 1 is perfect matching, that there is no reflection. Meanwhile, VSWR below 2 is considered good, meaning only a very small part of the signal is reflected. For this project, a VSWR of 1.15 means the antenna has excellent impedance matching, so nearly all the signal is transmitted with very little loss. For the conclusion is, my project is successful achieved model and simulation operate efficiently in 2 to 4 GHz in a compact size of Vivaldi antenna. I achieved S11 VSWR and radiation pattern that meets the standard requirement. And then thirdly is I do the comparative analysis of the simulation outcome, which means I do the analysis first before I get the results. I do 3 times measurement to get the best result in the compact size. This is the invention advantages. A compact Vivaldi antenna is a small size with high performance, making it ideal for applications like fault detection in power systems, where space and precision are critical. It is ultra-wideband antenna because of 2 to 4 GHz frequency range is wide frequency. We also enables detection of a broad spectrum of fault-related signal, such as partial discharge and arcing. The application of this antenna is it is suitable for all of kind power system, including overhead medium voltage distribution lines, underground medium voltage distribution lines, and also main switchboard. This is the commercial potential that I think it is have a high potential to integrate it in the system of this company. First is a compact and cost-effective solution. The antenna small size and low cost makes it practical for installation substation, MSB room, and renewable energy plant, unlike bulkier and expensive fault detection equipment, and unlike the traditional Vivaldi antenna. And lastly is smart grid integration. With IoT, Internet of Things or GSM connectivity, the antenna can prove real-time fault monitoring and remote reporting, supporting the move towards smarter, safer, and more reliable power system. Thank you very much.